Welcome to another Learning Together session sponsored by the Brosis Foundation. We're so happy to provide this additional resource for you, and we trust that you will share this information with other people who might benefit from these tutorials that we have in both English and math. We have two things going at this point. We have tutorials in English and tutorials in math. If you go to the Brosis Foundation website, you'll be able to get additional information, okay? We have been looking at rational expressions and rational equations, solving rational equations, and also simplifying rational expressions. What we decide to do today, to pull it all together, is to look at more complex rational expressions and also more complex rational equations. And what you will see is that once you understand the principle and you apply the math correctly, it all works out. So initially it might look very ugly, but after you apply step by step in a systematic way, the same principles, the whole thing comes together beautifully. So hopefully by the end of this session, you'll be more comfortable with these ugly looking rational expressions or solving these rational equations. So let me remind us of some of the things that we have done. I will start with something like this. If you were given 3 over 7x squared y plus 4 over 21xy squared, and you're asked to simplify that. Let me double check to make sure I copied it correctly. 3 over 7x squared y plus 4 over 21xy squared. Beautiful. Here we have two fractions, and we say that these are rational expressions because they have variables in their fractions, okay? And like anything to do with fractions, if we're adding, we must get a common denominator. So what do? We say, okay, we approach it the same way. We look at the denominators, the two denominators, and the common denominator must be something that 7 and 21 can go into without a remainder, and that is 21. We look at x squared and x. What is the expression that both x squared and x can go into without a remainder? It has to be x squared. You can't use just x because x divided by x squared would not work. However, x squared can be divided by x, and x squared can be divided by x squared. So therefore, x squared is the better choice. Similarly, we look at the variable y. This is y squared, so we must use y squared. So what is the key? The key is we use the highest exponent for each variable. That's it. Look at all the occurrences of the variable in all the different denominators and look for the highest occurrence, and that will be part of your common denominator. So that's our common denominator now, 21 x squared y squared. So now you ask yourself the question, what did I do to this denominator to get it to look like this? I think we multiply by 3 and we also multiply by y. So we are multiplying this whole thing by 3y to get this. So therefore we have to multiply the top by 3y. So we end up with 3 times 3y. Plus, what did we do to this? Well, 21, nothing. Y squared, nothing. So really, all we did was just multiply by x. You see? X times x gives me x squared. So it's going to be 4x. Okay? And then when I simplify that, what do I have? It's 9y plus 4x all over 21 x squared y squared. So when you put these fractions together, this would be your final result. Okay, so let's look at another one that involves more binomials and trinomials. Say, for example, we have 4 over y squared minus 25 plus 6 over x squared plus 6x plus 5. So we have two different denominators, and they don't look like they resemble each other at all. So how do we proceed? Well, let's go. We go step by step. We say this is equal to 4 over y squared minus 25. We already learned how to factorize. We know how to factorize. We realize this is a difference of squares. It's actually y squared minus 5 squared. And that is one of the classic factorization for difference of squares. This was covered in a previous session, a previous tutorial. So this will be the factorization of this. And I promise you, when you multiply these out and simplify, you will get that. Similarly, this is going to be 6 over x plus 1 times x plus 5. Again, if you multiply these out, I promise you, you will get this. So now we're ready to get our common denominator. Remember, I said previously that to get the common denominator, every factor in your denominator must be represented in the common denominator. So once it's in one of the original denominators, it must be accounted for in the common denominator. So now we're ready to rock and roll. Y plus 5. Wait a minute. Is it all y or is it? Oh, it's all x's. I am writing. It's all x's, it's not y. No wonder. That would have been a no-no. It's all x's. If it was y, then we really couldn't do anything at all. But it's all x's. Okay, there you go. So we have an x plus 5 and just one x plus 5. So therefore, x plus 5 is represented once. We have an x minus 5. There's no x minus 5, so it has to be here. And we have an x plus 1, it has to be here. Once it occurs, originally, it has to be part of your common denominator. So check this out. If you divide this by this, then the answer is going to be x plus 1. In other words, you're multiplying this denominator by x plus 1 to get this. So now I have to multiply the top by x plus 1. So now I have 4 times x plus 1. Plus, here's my 6. What is here that was not here? The answer is x minus 5. So I'm multiplying this denominator by x minus 5. So I have to multiply the numerator also by x minus 5. So we end up with 6 times x minus 5. And what we do now is, just so you know, going forward, you never want to expand your denominator. You always want to leave it factorized. You will expand the numerator and see if there's a way that you could cancel something in the denominator, if possible. So you combine like terms and then see where you fall, if you can do anything. So here we go. We have our x plus 5, x minus 5, x plus 1. And now we end up with 4x plus 6x is 10x. And 4 minus 30 is minus 26. Let me double check. 4x plus 6x, 10x. 4 minus 30 is minus 26. And truthfully, there's nothing dramatic happening. As a matter of fact, we can't do anything with this because the top, all that we're going to get at the top is factor out to 2, we end up with 5x minus 13 over the 3 denominators. So that's the best we can do. There's nothing else we can do with this because nothing canceled out. So that's what you do for that question. Okay? Let's look at another one. Okay, so now we have x plus 2 over x squared plus 4x plus 4 plus 2 over x plus 2. So lots of things going on here. And the question is, can we combine it? Well, based on where it is right now, as I've always said, the first step is to factorize your denominator, then you get your common denominator. So here we go. This is x plus 2, and at the bottom we end up with x plus 2 times x plus 2. That is plus 2 over x. If you're looking carefully, you notice that, this cancels this. So technically we have, and then we just have x plus 2 and x plus 2. So we have 1 over x plus 2 plus 2 over x plus 2. The denominators are the same, so we can put them together and just add the numerators. So we end up with 3 over x plus 2. So that was a pretty cool ending for that one. Let's go to one that looks a little bit more involved and see if that works out also. So hopefully by now, you're starting to see a pattern as to how to approach rational expressions. You know, as you get them, you just take a look at them and then you decide what direction to go. And after a while, they become very comfortable and you're not scared anymore. So let's look at this one. This one seems to be a little bit more involved. Let's see. 4 over x squared minus 3x plus 6 over 3x minus 9. Okay, 4 over x squared minus 3x plus 6 over 3x minus 9. Again, we factorize first and then we get our common denominator. So we end up with 4 over x times x minus 3. That's the best you can do. X is common to both terms, so we factor out our x, then you left with x here and you left with negative 3. If you multiply these out, if you distribute, you will end up back here. Plus 6 over, what is common to these two? Just 3. When I factor out a 3, we end up with an x minus 3. And so now I notice that we have x minus 3 and x minus 3. We have an x here and we have a 3 here. And I said to you that all factors must be represented in the common denominator. So therefore, now we're going to have 3x times x minus 3. So the x is included, the 3 is included, and the x minus 3 is included. So everybody is at the table. Everybody is represented. Okay? So now we need to modify the numerator since I modified the denominators. Okay? So what did I do to this? I introduced a 3. There's a 3. There wasn't a 3 before. So I'm multiplying this by 3. So therefore I have to multiply the top by 3. I get 12. Plus, what did I do to this denominator to make it to this? I introduced the x. I multiply by x. So therefore I have to multiply the top by x. So I end up with 6x. And now we're going to go and see if there's anything else we can do with this. I notice that I can factor out a 6. Okay, so the top is really 6 times x plus 2. I switched them around and just factor out the 6 and got x plus 2. And the bottom is 3x times x minus 3. And then I can see here that all I need to do is to divide the top, divide by 3, and I get a 2. So it's 2 times x plus 2 over x times x minus 3, and that's it. And that's it. So this is what we started with. This is what we ended up with. Okay? Now, we're going to switch gear in a couple minutes and go to equations, but I just want to do a couple more just to seal the deal right now. So here's one. This one looks a little bit more, we'll see. I'm surprised there's no minus on these right here. Okay. Oh, here's one. Y over 4y plus 8 minus 1 over y squared plus 2y. Y over 4y plus 8 minus 1 over y squared plus 2y. Okay, what do we have? Well, let's factorize. So it's equal to y over 4 times y plus 2 minus 1 over y times y plus 2. Okay, so now we're ready. Now we can see our denominators. Okay, you see now that the common denominator will have to have a 4, a y, and a y plus 2. So it's 4y times y plus 2. So this one was multiplied by y, so now we have a y squared. This one was multiplied by 4. So now we end up with 4 times negative 1 gives me negative 4. And you might say, uh-oh, we're done. And I say to you, no, we're not. Because I noticed that the top is a difference of squares. This is y squared minus 2 squared. So the difference of squared is a squared minus b squared is a very powerful algebraic expression that is called the difference of squares. You'll see whenever we have something squared minus something squared, that's called the difference. And you know in math that subtraction is differences. Find the difference between two numbers, you subtract. And what is a square? Is something to the second power, something to the second power. So you have a square minus a square, difference of squares. It's a literal translation. Okay? So that is factorized by y plus 2 times y minus 2. That's what this difference of square is. It's y plus 2 times y minus 2. I guarantee you that if you were to distribute, this is what you will get. And what do we have on the bottom? We have 4y times y plus 2. And I say, uh-oh, I have a y plus 2 and I have a y plus 2 on top. They cancel. So now we end up with y minus 2 over 4y. So this was a good ending for that question right there. Nice, beautiful, simplified version. Okay? And the only thing that can create any confusion is when you have a fraction over a fraction. For example, look at this. 1 over x minus 2 divided by 2 plus 1 over x. Now, this is what I was talking about when I say ugly. That's ugly. So let me take a sip of water and then we'll tackle it. Okay. Okay. So we have a fraction divided by a whole number plus a fraction. So the recommendation is make this into one fraction, and then whenever you're dividing by a fraction, it's a very important mathematical principle. What do I mean? If I give you a plus b divided by x over y, this is so important, and there's so many students who still struggle with this concept. You don't need to, it's just knowledge. It's just knowledge. Whenever you divide by a fraction, you flip the fraction and you multiply. So it's actually going to be a over b times. Flip the fraction becomes y over x. So that would be the final answer. AY over bx. You divide by a fraction by changing the division to multiplication and changing the fraction where the bottom becomes the top and the top becomes the bottom. What do I mean? Let's do some numbers. If I gave you 8 over 3 divided by 2 over 9. 8 over 3 divided by 2 over 9. Many students would have trouble with that without a calculator. And I'm saying to you, we need to be able to do the math without a calculator, or at least, if we're going to use a calculator, understand how the calculator processes the question. So, what is done? It's 8 over 3 times. Flip this, you now end up with 9 over 2. So now you have 8 on top, 2 on the bottom. 8 divided by 2 is 4. 3 on the bottom, 9 on top. 9 divided by 3 is, so the answer is 12. I guarantee you, if you were to take this and put in a calculator properly, you will get 12. What does properly mean? You'd have to put 8 over 3 divided by parentheses 2 over 9. If you don't put the parentheses here, you may not get the right answer. As a matter of fact, I guarantee you it will give you the wrong answer. However, once you put the fraction, the parentheses, it works perfectly. Okay? Good. So now let's go here now. So I need to convert this into one fraction, and then we can flip and multiply. Like a courtroom scene, I call what I just did here a sidebar. So it's a teachable moment. I came to the side and review how to divide by a fraction. And now we're going to use that knowledge in rational equations and rational expressions. So here we go. So this becomes 1 over x minus 2 divided by, now I'm going to work on this right now. So it is 2 over 1 plus 1 over x. It's 2 over 1 plus 1 over x. Anything I give you, 6, I can write as 6 over 1. It doesn't change the value. If I gave you y, you can write that y over 1, because anything divided by 1 is the same thing. It doesn't change. So I can, if I gave you the number 8, I could still put it as 8 over 1. It's equivalent. They are the same value. Okay? And that becomes very helpful when you're doing questions like these. So now we're going to make it a common denominator for 1 and x is x. So what do we have? This fraction is ready, but we're fixing that. So it's divided by, common denominator is 1 times x is x. So this 1 was multiplied by x to become x. So therefore I have to multiply the top by x to get 2x. And this is already x on the bottom, so just put plus 1. So now we have a fraction to divide by, we're dividing by a fraction. So now we can flip and multiply. So therefore the question becomes 1 over x minus 2 times, when I flip it, I get x over 2x plus 1. Okay, so the final answer is going to be 1 times x is x. And then put these two together, x minus 2 times 2x. That will be the answer for this question. Okay, I think we need to do one more question similar to this. Okay. Let's see this question. 3 over x plus 1 over 5 over x minus 1. Okay, what is that equal to? Kind of ugly. So it is equal to 3 over x plus 1 divided by 5 over x minus 1. So you're dividing by this fraction. You have this fraction divided by this fraction. So we end up focusing on the divisor. This is your divisor. This becomes a multiplication. This changes to x minus 1 over 5. So your answer is 3 times x minus 1 over, it's better to put the 5 in front, 5 times x plus 1. And that would be the answer for that question. Okay, I see another question similar to this, so I'm going to do that and then I'm done with the fractions. Okay, and then I do one last question in that section and then we move to equation. Okay, so you're getting a lot of exposure, a lot of practice with rational expressions. This one says 2 over x plus 6 divided by 1 over y. Okay, so what do we do with this? Anybody remember the name of this line? Anybody remember the name from a previous session? Ah, yes, it's called the vinculum. It is the line that separates your numerator from your denominator, your vinculum. Okay? And I said to you, we always keep the equal sign on the vinculum on the same level. Okay, so now we have this, and then of course I told you, put this over 1. I'm going to make this into one fraction. It becomes, this becomes, x times 1 is x. It's going to be 2 plus, this must be multiplied by x to get this. So x times 1 is x. So this becomes 6x. And you're dividing by 1 over y. And what did we discuss? We discussed that When you divide by a fraction, you flip and multiply. So now we have, and these two can be factorized. You can take out the 2, you end up with 3x plus 1. I just switch them around. So it's 3x plus 1. Standard form, highest exponent to the lowest. It just looks better. You don't have to, but it looks better. So it's that over x times, flip that, is y over 1. Okay? And finally, this becomes 2 times y is 2y times 3x plus 1 all over x times 1 is x. And that was the answer for that question. And your final question on rational expressions, simplifying rational expressions, is as follows. Final question is 2y over y squared minus 4y minus 12 plus y over y squared minus 10y plus 24. So this is our final question in this section, and we'll see what happens here. Well, as discussed previously, the first thing we do is we factorize the denominators. So now we have 2y on top, and this is y minus 6 times y plus 2. That's what you do when you factorize this is what you get. Plus y over, and this one becomes y minus 12 times y plus 2. Okay? So what is the common denominator? And what I said previously is that we must have representation. Every factor in your denominator must be a part of the common denominator. So y minus 6, there's no y minus 6, so y minus 6 has to be represented. Y plus 2 has to be represented. And y minus 12 has to be represented. Now, when you look at this fraction, what was introduced to this denominator? We say, oh, y minus 12 was introduced. So therefore, we take the y minus 12 and multiply times the top. So now we have 2y times y minus 12 plus. What's the difference between this denominator and this? We see a y minus 6. So we have to take the y minus 6 and multiply the top to keep it the same fraction. So it's going to be y times y minus 6. We never expand the denominator, never expand the denominator. However, the numerator, we expand, simplify, and then see if possible, if anything can cancel from the bottom. So let's go. So this is going to be 2y times y, 2y squared. 2y times negative 12, negative 24y. Y times y, y squared. Y times negative 6, negative 6y. And we have a y minus 6, y plus 2, and y minus 12. So let's simplify this way. Number 2y squared plus y squared gives me 3y squared. Then what else? Negative 24y minus 6y is negative 30y. So when I look at this, all over these two denominators. When I look at the top, I can factorize out a 3y times y minus 10. When I look at the bottom, nothing can be cancelled. So I just end up with this. And that would be your final answer. There's nothing to cancel, so that's the best you can do. So now we're going to go to more complex rational equations. Okay, so, here we go. Solve. So now we need to solve 1 over 2x plus 2 plus 5 over x squared minus 1 equal to 1 over x minus 1. So 1 over 2x plus 2 plus 5 over x squared minus 1 equal to 1 over x minus 1. So here's the principle. Your number one objective is to get rid of all fractions. Get rid of all fractions. And the easiest way to do that is to multiply by the common denominator. That's the easiest way to do it. Okay? So how have we been finding the common denominator? We have been actually factorizing each denominator first, and then we create our common denominator. So this becomes 1 over 2 times x plus 1 plus, if you look at this, you realize that it's a difference of squares. It's x squared minus 1 squared. So it's actually x plus 1 times x minus 1. That's what that is. If you didn't see that, then you would not be able to simplify it properly. But once you see it, it becomes easy for you. Equal to 1 over x minus 1. So, do you realize that the common denominator is actually this? This is a common denominator because every denominator can go into this. This can, I lied. The common denominator is 2 times this, because remember I said every factor in the denominator must be represented in the common denominator. So I'm saying to us that if I multiply both sides of my equation by 2 times x plus 1 times x minus 1, that will get rid of all the fractions. So when I multiply this by 2 times this, then the 2's cancel, the x plus 1 cancel, and I'm left with just x minus 1 times 1. So it's going to be 1 times x minus 1 plus, when I multiply this fraction by 2 times x plus 1 times x minus 1, the x plus 1 and the x minus 1 cancel this, and I'm just left with the 2. So it's going to be 2 times 5. When I multiply this fraction by 2 times x plus 1 times x minus 1, the x minus 1 cancel, and I'm left with the 2 times x plus 1 times 1. Look what happened. We came from ugly to simple, from complex to simple. And this is just a simple linear equation. We just solve and get our answers. So it's 1 times this gives me x minus 1 plus 10 equal to 2x plus 2. If I subtract 2 from both sides, we end up with 7 equal to, if I subtract x from both sides, we get x. So therefore, x is equal to 7. Let's double check to make sure we did it correctly. Okay, this is 2x plus 1. This is x plus 1 times x minus 1, da 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 da. So we're going to multiply by 2, x plus 1, x minus 1. So we get x minus 1 for the top. For this one, we only get 2 times 5 is 10. And for this one, we end up with 2x plus 1 times 1. There it is. So if 7 is correct, when I plug in 7 for the left-hand side and simplify, I should get exactly what I get when I do on the right side, if it's correct. So let's go and check. Keep your fingers crossed. Okay? So for this, for the left-hand side, LHS means left-hand side. We have 1 over 2 times 7 is 14, plus 2 is 16, plus 5 over 7 squared is 49, take away 1 is 48. What is that equal to? Well, common denominator is 48 because 16 goes into 48 3 times. So we're going to put 48 here. 16 into 48 is 3. 3 times 1, 3. This is already 48, so I can put plus 5. There's no change because we already have 48. 3 plus 5 is 8 over 48. What is 8 over 48? Divide top and bottom by 8. We end up with 1 over 6. So the left-hand side is 1/6. Let's go to the right-hand side. Right-hand side is equal to 1 over 7 minus 1 equal to 1 over 6. 1, 6, 1, 6. So we are good. Okay? Let's do another one. Now, if you're asked to solve a rational equation, you don't have to go back and check your answer. I'm just checking it to show you, to demonstrate, to model that the process does work. That's all. Okay? Really, a good student, when you get to a certain level, can be in a position to know whether the answer is correct. And that person doesn't have to wait for the teachers to say, good job. They already know because they have checked their work and realize that, oh yes, it works. It fits. Okay. So that was a nice welcome. Let's try another one. Let's try 5 plus 5 over x equal to 6 over 5x. 5 plus 5 over x equal to 6 over 5x. Okay, so this is 5 over 1. So we're trying to get rid of all the denominators. So what is the common denominator? The common denominator is 5x, because 5x can be divided by 5x. 5x can be divided by x. 5x can be divided by 1. So I'm saying to us that once you find the common denominator, all you have to do is to multiply both sides by the common denominator. So I'm going to multiply the left-hand side by 5x and the right-hand side by 5x. So we have 5x times 5 plus 5 over x equal to, multiply the other side by that too. What do we get? 5x times 5 is 25x. 5x times 5 over x. The x cancels the x. We end up with plus 25. Then we come over here. 5x times this cancels that. We end up with 6. So now we have transformed from a rational equation to a two-step linear equation. Okay? Subtract 25, we end up with 25x equals to negative 19. Divide by 25, x equal to negative 19. And that will be the solution to that question. Okay? Let's look at another one. This one says 4 over x minus 3 equal to 2 over x plus 1 plus 16 over x squared minus 2x minus 3. Good practice is to check your answer to make sure you don't have any transposition errors. Or when you copy it, you transpose it, make sure you don't make an error where you switch things around. So it's 4 over x minus 3, 2 over x plus 1, plus 16 over x squared minus 2x minus 3. So that's good. So now we need to factorize this. What do we have? 4 over x minus 3 equal to 2 over x plus 1 plus 16 over x minus 3 times x plus 1. Again, if you're in doubt, you can multiply this out, expand this, simplify, and I guarantee you that's what you get. Okay? So what's the common denominator? This embodies all the denominators. So this is the common denominator. It is divisible by itself. It's divisible by x plus 1. It's divisible by x minus 3. So now we're going to multiply both sides by this common denominator. So picture me putting a square parentheses instead of square brackets, not square parentheses, instead of square brackets, and then outside putting x minus 3 times x plus 1. In other words, I'm multiplying the entire equation by the common denominator. Look what happens. X minus 3 cancels x minus 3, so we end up with 4x plus 4. Allow me to just do the two steps in one. I do the cancellation and I do the expansion, the distribution. So 4 times x plus 1 gives me 4x plus 4. Come to this one, x plus 1 cancels x plus 1, we're left with x minus 3. So it's 2 times x minus 3, giving me 2x minus 6. It's a plus. So now when I multiply this times this fraction, this cancels this cancels that, so we're just left with 16. Now, complex simple. Subtract 2x, remove the 4, so we end up with 2x equal to negative 6 plus 16 is 10. 10 take away 4 is 6. Okay? And therefore, x is equal to 3. Okay? Now, this answer we got 3. I'd introduced a word to you, I think last time we met, and that word was extraneous. or I should say expression, extraneous solution. What are extraneous solutions? These are numbers that actually fit the problem mathematically or algebraically, but they are invalid. I want you to listen to me carefully. Mathematically, they work, but when you try to apply them to real life, they do not work. Okay? Why is this an extraneous solution? Because when I put 3 here, 3 take away 3 is 0. When you try to divide by 0, you end up with undefined. You cannot divide by 0, it's undefined. Okay? It's almost like tending towards infinity. In this case, it will be positive infinity. Okay? But let's not even go there. It's in math word, it just says undefined. You just cannot divide by 0. So because 0 came out to be the solution, when you plug in 3, so because 3 became the solution, we plugged it in, it does not fit. It creates a conflict. Then we call it an extraneous solution. Another example that I would give you, I always use this example. The example says that the area of a square room is 225 square feet. Find the length of one side. But it's a square. So if this is x, this has to be x, this has to be x, this has to be x. Okay? Of course, my diagram is ugly. So let me draw it better so you can appreciate it better. Ah, that's better. Okay? And you're told that the area is equal to 225 square feet. But we know that the area is length times width. So we know that x times x is equal to 225 square feet. So x squared is 225. So now, back when we did quadratic equations or we did equations of higher degree, we discussed that the highest exponent tells you how many solutions. So this is a quadratic equation because the highest exponent is 2. It's quadratic. If it was 3, it would be cubic, etc., etc. So this is saying that you have 2 solutions. How do you get rid of square? You do square root. So we find the square root of both sides. So therefore, x has to be equal to plus or minus the square root of 225 is equal to plus or minus 15. And the square root of feet squared is feet. But check this out. 15 feet makes sense, but negative 15 feet is nonsensical. It does not make sense. So even though mathematically it fits the profile of what we're doing, practically the negative 15 is meaningless. So what we say is that 15 is the solution and negative 15 is an extraneous solution. So it's a mathematical solution, but it doesn't have any practical value because you don't have a negative length, you cannot have a negative distance. You can tell someone that when somebody asks, how far do you live from here? Oh, I live -4 miles away. That's meaningless, okay? Good. So most people go through their lives and go through math, never hearing about extraneous solutions. Well, now you know differently. Okay, so let's look at this one as we get ready to close. So this is 7 over x squared minus 5x plus 2 over x equal to 3 over 2x minus 10. So quite a few things happening in this question. 5x squared minus 5x plus 2 over x equal to 3, 2x minus 10. Quite a number of things happening. So as always, we factorize and then we look for a common denominator. So here I'm seeing 7 over x times x minus 5 plus 2 over x equal to 3 over 2 times x minus 5. So by now you can see that the common denominator has to incorporate x, x minus 5, and 2. It has to take into account all these factors, the x minus 5, and 2. So we're going to multiply both sides by 2x times x minus 5. That's what we're multiplying by, both sides. And that will eliminate all fractions. When I multiply this one by that, the x cancels the x minus 5 cancels the x minus 5, and I'm left with 2 times 7 gives me 14. Plus, when I multiply that times this, the x cancels the x, so now I'm left with 2 times x minus 5 times 2. Look at it, the x cancels this x, so you have 2 times x minus 5, and you have 2 on top, there's a 2 right there. Over here, when I multiply this times this, the 2 cancels the 2, the x minus 5 cancels the x minus 5, you're left with x times 3, and that gives me 3x. So now, we can multiply, this should end up with 14 plus 2x minus 10. Oops, I just realized there, but 2 times 2 gives me 4. So 2 times 2 is 4, 4 times x is 4x, 4 times negative 5 is negative 20, equal to 3x. And now we have 14 minus 20 is negative 6, so 4x minus 6 equal to 3x. So add 6 to both sides, subtract 3x from both sides, x is equal to 6. Does that work? Well, let's check and see what happens. So we're going to plug in for x on the left, plug in for x on the right, see if the left is equal to the right. Okay, so go left hand side. Using 6, so 7 over 36 minus 30. Look at it, 6 squared is 36, 5 times 6 is 30, plus 2 over 6. That's going to be equal to 7 over 6 plus 2 over 6. So that seems like it's 9 over 6. And if it's 9 over 6, when I simplify that, I end up with 3 over 2. So 3 over 2 is what's the left-hand side equal to, 3 over 2. So let's go to the that's what the left-hand side is. Let's go to the right-hand side. We end up with 3 over 2 times 6 is 12. Take away 10 is 2. So we have 3 over 2 3 over 2 equal to 3 over 2. And we just have one last question, and that's it for the day. One grand finale. Let's see what it is. I see this question. I'm not sure if there's anything to it, but I'll do it just to make sure that we did not miss anything. So this one says x plus 3 over x squared plus 3x minus 4 is equal to x plus 2 over x squared minus 16. This is a grand finale. Let's see if we can get this done properly. So we're going to factorize the denominators. We end up with x plus 3 over, this becomes x plus 4 times x minus 1. That's the factorization of this. X times x squared, x times 1, negative x. 4 times x is 4x, take away x, 3x. 4 times negative 1, negative 4. And then this is going to be equal to x plus 2 over, when you look at this, you see it's a difference of squares. It's actually x squared minus 4 squared. So it's going to be x plus 4 times x minus 4. So you have noticed that difference of squares comes up a lot. So if you're paying attention, you will always be looking out for that coming up. Okay, what's the common denominator? The common denominator will include x plus 4, x minus 1, and x minus 4. So it has three binomials. Okay, so we're going to multiply both sides by x plus 4, x minus 4, and x minus 1. Those are the three factors that will make the common denominator. So when I multiply this, the x plus 4 cancels the x plus 4, the x minus 1 cancels the x minus 1, and we're left with x plus 3 times x minus 4. I hope you're paying attention because this took us to another level. We never had one of these before. And now this, when I do the same thing, we're left with x minus 1. This cancels that, this cancels that. So it's going to be x plus 2 times x minus 1. Expand. So this gives us x squared minus x minus 12. This one is going to give us x squared plus x minus 2. Yes? Subtract x squared from both sides, these cancel. When we subtract x squared from both sides, they cancel. Add x to this and add 2 to this. We end up with negative 10 equals to 2x. So negative 10 is equal to 2x. So therefore, x is equal to negative 5. Is it correct? I don't know. Let's check to see if it works, and then that's it. Let's call it a day. So, left-hand side. When x is negative 5, it's going to be negative 5 plus 3 over negative 5 times negative 5, 25. 3 times negative 5, negative 15. Minus 4. What is that equal to? Negative 5 plus 3, negative 2. 25 take away 15 is 10, take away 4 is 6. So that's going to give me negative 1/3. So negative 1/3 is what the left-hand side simplified to give us. Keep your fingers crossed. Hopefully the right-hand side works out to be the same thing. Otherwise we got knocked out. So let's go. Right-hand side is equal to, again, x is -5. So it's -5 plus 2 over -5 squared is 25 minus 16. What is that equal to? -5 plus 2 is -3. 25 minus 16 is 9. So -3 over 9 is negative, divide top and bottom by 3. 3 into 3 is 1. 3 into 9 is 3. Is that the same as this? Absolutely. So we have had an exhaustive run into rational expressions and also rational equations. I spent this extra time on this particular section of math because I've observed a lot of students get nervous when they see fractions. Just regular numbers, regular fractions, they get nervous. Much less if you have a rational, meaning that you have a variable in your fraction. Wow, that's like, no. But hopefully, based on the number of questions I've done, the number of questions I've modeled for you, you should see, wait a minute, it's pretty consistent how you approach these. And if as long as I do the steps correctly, I will get to my correct destination. Hopefully that's what happens in your case. On behalf of the Brosis Foundation, we're so delighted that you joined us. We hope that you got some exercise in mathematics. We hope that you were intrigued by the challenges that you saw. And we also hope that you would share this information with others. Brosis Foundation, where we learn together in both English and also in math. And as for now, I'd like you to enjoy the rest of the evening, and I look forward to having you join us for another Learning Together session.